In this episode of Cloud Performance Atlas, I help some urban developers get their sensors straight. Will we be able to find parking in time? Stay tuned to find out. Like most IoT companies, Urban IoT makes their money deploying hordes of sensors in an urban area that monitor everything from noise, temperature, and humidity, which of course means that the majority of their data that they collect from those devices consists of timestamps and simple floating point numbers, the volume of which quickly started showing a problem with Datastore performance. See, Cloud Datastore is built on top of Bigtable and thus is subject to its performance characteristics. Bigtable scales by sharding rows into separate tablets, which are basically a contiguous unit of storage. And when a tablet experiences a high write rate, the tablet will split, allowing it to scale even further. The important point here is this. Rows in the tablet are ordered such that it helps distribute the workload amongst multiple tablets. They do this by sorting the rows lexicographically by their key. And as long as the keys are randomly distributed, this sorting works pretty fine. However, if your keys are lexicographically close, then your performance starts to suffer as your operations can be isolated into a small update window, which, lo and behold, was exactly what Urban IoT was doing. Turns out their federation of IoT devices were pushing sensor readings into Datastore and using the timestamp as the key for the entity so that they could easily fetch and display the results later. Timestamps, of course, are a monotonically increasing value, which is being used as an indexed property, which led right into the hop spotting scenario that we were worried about. Now, here's the really interesting part. This behavior was really hard to repo on our side. I mean, we set up a 250 QPS load test creating entities with keys that are timestamps over a 20-minute window, and didn't see anything. Datastore did an amazing job at absorbing that level of work, no problems whatsoever. In order to actually see this behavior, we had to jack the QPS up to 750 and let the test run for over an hour. You can see that over time it takes a little longer to handle the same operations. For Urban IoT, the least invasive fix for this problem was to append a random prefix to their timestamps, which caused some headaches in their dashboard for fetching, but also allowed their performance to land back in the non-hotspotted area. Now, I just want to highlight something again. This is not a standard run-of-the-mill performance issue. It took a couple of days of really hammering on Datastore to get our test to behave the way that Urban IoT was seeing in the wild. And my guess is that unless your use case is very similar to theirs, chances are you won't run into it. So if you'd like ideas on where to spend your time instead, make sure you check out the rest of the Cloud Performance Atlas content, because when it comes to performance, every millisecond counts.